right, so everybody's good with this so far? Just be careful of the continuously. When it says continuously, make sure you're using curve. All right, did we do this one too?
No, we didn't do 3 and 4.
2, did we do 2? Let me ask the people that paid attention. Did we do?
I had stuff written down.
Ah, but you didn't have the whole thing done. Okay. All right, did we do this one?
We did 4.
We did 4? We did 4. I remember doing 4 with you because we were trying numbers in there to see what happens. Okay, check 3. 3 is the compounded monthly. Don't forget to put your interest rate into a decimal. Even if it contains a decimal, you still need to move the decimal 2 places over. Otherwise, you're getting a lot of money back. If you find yourself getting a lot of money back, something went wrong. Amani, you have the homework? Oh. Reagan. Sarah. All right, as we move along, how'd this one look? This is one we did in class 2, right? Yes, this was the interest rate. Just be careful on the interest rate. Remember, the number is small. And I think actually you caught the window. Change your window and you can see it. It's actually there. We didn't intersect with it there. Most of these go pretty smoothly. Good morning. It's only 26 degrees out there.
That's not that old.
Someone needs to get in those big, what are those girls wear? Those leg warmers? Leg warmers. Back in my day, we used to wear those. Yes.
For number 7, why is P1? That's the only thing I need to know.
Why is P1?
Yeah.
We were doubling, so I made it 2 to 1. 100 to 200, 10 to 20. Yes.
For number 6.
Number 6.
For some reason, like, since I thought since it says compounded monthly, you had to like convert 5 years into months.
Oh no, compounded monthly is the end. Whenever you say the compound word, that's end. So compounded monthly N is 12. You're still working time in years. Your time is still years. That, you have to change it if it said after 5 years, and then I gave you well, if it said and if it said it collects interest every yearly, then you would say if I gave you a month, you'd have to convert it to a half a year or something like 6 months, half a year. Those kind of things you'd have to convert. But interest is usually done for like an entire year. So annual, they're only going to compound it once a year, meaning they're only going to give you your interest rate once a year. Semi-annually, they're going to calculate your interest rate twice a year. Monthly, they're going to calculate it 12 times a year. You still don't get that interest rate every month. They separate, they have some kind of an algorithm. I don't even know how they do it, but they calculate parts of it and add it to your account every month. So like if you look at your bank statement, usually your bank statements are sometimes either monthly or every 3 months they come out, and they'll give you the interest rate. Usually it's monthly or 3 months. But they just add that in. But your interest still goes by the year. That's a very good question, because that always is a little confusing point. Everybody catch what Allie just asked me about? Even though we're calculating our interest rate yearly, it is processed monthly, semi-annually, quarterly, and it's added to your account. If you look at a bank statement, you'll see your interest sometimes monthly, sometimes every 3 months. But it is for an entire year. Yes.
Did we do the other package?
Yes, we're going to finish this one first and then go back to the other one. Everybody good with this?
So that was the last question.
And we didn't have to do this one. I didn't give you this one because it was just a series of, guys in the back, it was just a series of inputting. And is everybody okay with the daily is 365? The monthly 12, annually is 1. That means only one time a year is your interest calculated. Quarterly, continuously, and daily are the closest. I looked this up before because modeling does a lot with interest rates. and they ask you like what percentage is actually calculated by the month, by the day. And so I looked them up before, and they work out pretty close together, those two. No, no, so you're just plugging it in. You basically did that above too, but I just wanted you to make sure that you catch the end for each one. Daily 365, monthly 12, quarterly 4, semi-annually 2. Everybody's okay with this? I didn't ask you to do this. I told you we have a couple of ninth grade classes in this room. Childless. Remember back when you were in ninth grade? I bet you've grown up, right? Are you in this very room? Oh. Oh, Miss Gray? Yes, this was her room. Yes. Okay, so we're assuming the rabbits are doubling. So remember, we start off with this. This is my rate. My rate is double every month. So now time is month. So Allie, this would be one of those things. If I said what happens after 5 years and your time is in months, you would have to convert that to months. This is where you were thinking probably. Usually the interest works normally. And there are initially 20 rabbits. A is your 20. X is your time. This time, it is in months. How many rabbits are present? Yeah, so is this an increasing or decreasing function? Increasing. So we know our increasings, they all work like this. Okay. Now, this is the part we don't want because we can never have negative time. We want the piece that goes like this. How many rabbits are present after 1 year? After 5 years. Here's the problem. Since your time is in months, and this is in 1 year, you have to give this in months. 12 months, 60 months. You have to plug that in. So in your time, sorry, this got caught in there. In your time, you raise it to the 12, you raise it to the 60. This is a very, very, very large number. You know how fast rabbits multiply? That's a really yeah. But 5 years with all those rabbits, they all keep multiplying. Every time one multiplies, and then that one can multiply, and that one can multiply. And you can leave this as a scientific notation number.
How do you know when to put like the episode of the
When you have a cycle, if it something doubles if it doubles every 4 days, and you're doing every 4th day.
So why do I put that?
Because every year, every month, every day will be fine. Every group of days will be a cycle. If it did every 4 months, we would have to put X over 4. Months is your like denomination, if you will, like feet, inches, so days, months, years. So that's what it's being counted in. Every 4 would be your cycle. Like it's not going to be every month, every year, every day. But X is whatever thing you're gathering: months, years, days, minutes, seconds, feet, inches, whatever it is you're doing, that time for that. Is everybody okay with this? What part bothers you? Okay, so you're going to start it always like this. Write this down every time you do one of these. They all follow the same thing. And you start this way. The population doubles. This is the rate. This is my initial. This is my rate. This is my time. So my rate doubles, goes in here. So far I have this. Do it one step at a time. Every month, every means X is good by itself, but X now, instead of being year, is in months. Okay. How many, initially, here's my initial. We started with 20 rabbits. That's my initial. We have to have a starting point. So now I can build my 20 in there. 20 times 2 to the X. And if we're going to just plug in the time is the variable. 1 year, since we're looking at months, how many months is 1 year? 12, so we would plug in the 12 for this. If 5 years, how many months is 5 years? 5 times 12, 60 months, we would plug in a 60. this part says determine when. So I'm looking for X, my time in months. In how many months will my rabbit population be 10,000? Put that in your, I guess we didn't do that part. Put that in your Y2, 10,000. And see where they intersect. It's probably underneath this. See where they intersect. Now the problem is the window. The window is the problem. So when you plug this in, this is a good indicator. You need at least 10,000 in your Y max. Your mins are both going to be zeros. Your Y max, it's going to be 10,000. That you need to see where it intersects. Make it 20,000, just so that you get enough room to intersect. And then you should see it. Look at your table. Look at your table after you put it in Y2 and see which one comes close to that. So when we intersect, it happens somewhere between 8 and 9 months somewhere. Makes a little bit more sense now. You have to work off of Y equals AB to the X. This works for everything. If this is a decrease, say a half-life, then a half goes in here. If this is my population is increasing by 15%, then I'm going to do this. If it's decreasing by 5%, then I'm going to do this. This is always my rate. We do the same thing with your interest formulas, only we compound with your interest formula. You'll not see compounding whenever you do these. Only with money. Only money compounds. Which means it calculates it more times per year. And when you start looking for banks, you'll look to see what gives you the best interest rate, right? You want to find a bank that gives you the highest interest rate. And you also want to look at how often they calculate your interest. Well, if you're only going to calculate it once a year, I'm better off going to a bank that compounds quarterly, right? 4 times a year. My money will be there for me. This guy, oh, this isn't increasing, where our town is growing, our population is growing. So remember, they all follow the same, either they're going to go this way for an increase, or they're going to go this way for a decrease. And our situational one is always going to be quadrant 1. So you always have to have a starting point. Where are you starting from? That's your intercept. Again, I'm increasing at a rate. Here's my B. This is my increase. I put my increase in here. This is my B. My initial population is 475,000. This is my A. Each year. So X is my time in years. Your complete graph comes from the other side. Your situational graph is just quadrant 1. Determine when it will be 1 million. This is your Y2. So now, when you do your Y max, what should you set your Y max at? Where are you going to set your Y max at when you do your table? Where do you want to see it? Where do you want to see it intersect at? 1 million. So what should your Y max say? Yeah, at least 1 million, right? Probably go a little bit higher, or it's going to be sitting right at the top. You can still do an intersect right at the top. Because most of your information comes out at the bottom. Sometimes if you went into the bottom quadrant, sometimes you had to move it over because it gets into those little words. The top usually is fine. Make it 1,200,000. Get it a little higher. This is a good indicator. When you do an intersect and you're increasing, that's a good indicator where your max is. A decreasing, a good indicator is where was your A? What did you start with? That's where you want to start and go down. Years, I set mine at 20, and if 20 doesn't work, I double it. Try that. Or look at your table. When you go to your table, here's your Y1, here's your Y2. You're looking for this to be 1 million, or if you set it to like 1,200,000, you're looking for where did these come close to each other. That'll give you that X value. Now you know where to make your X max approximately. The hardest part of this is setting the table, but you have to make sense out of the situation. If you're decreasing, then your initial value is your Y max. Got to play with your X a little bit. Look at the table, take a guess, try it. If it doesn't look close, double it. If you're really not close, increase it by a lot more. And you can't expect, you have to think logically. That's almost it's a little bit more than half of a million that they lost, right? It's a little bit more, that they gained to come up there. It's a little bit more than half of a million that they had to gain. It's going to take a little bit of time, at about 3.5%, 4%. It's going to take time to get up there. So it's not something that's going to happen in like less than 10 years. Make sense? Is that the date on it? What date did I give you tomorrow? Yeah. Mm-hmm. Let me get through this and then we'll talk about that. Did we do this one? Or you had to do this one? You had to do this. Okay. Alright, now this one is set up a little differently. We give you the population for a certain year. And we're saying our population is increasing. Determine the population in the town in 1915 and 1940. So how am I going to find my X value now? Subtract those. I can't put 1950 in for my X value. I want the years since 1980. That's my base year. That's like my year zero. That's my initial value. So first thing I do is subtract those two things and find out what my X is. All I got to do is plug them in. Okay. What is it going to be in 50 years if this keeps increasing? What is it going to be in 25 years if this is increasing? And this is probably a good situational graph for some towns. Yes. Well, you need a whole number for people. You need a whole number. So you're going to have to round to a whole number. Because this time you're counting people. Yeah. So you never have a population that says 0.5.
Would that be adding an extra person?
Well, the thing is you want to round up because at this point you haven't reached it yet. So you're going to have to round up to it. They're both round up. So you mean round down? Because you haven't reached that mark yet? Yeah, that'd probably make more sense. Either way, round up or down, yeah, probably. Because you haven't reached that new person yet. I totally see it. So if you keep this at 156, 88. Yeah. That would make sense. Good with this?
Yeah.
Now, don't forget, sometimes the problem will say, okay, the initial population was 6,250. In what year will it be, say, 50,000? So in what year, once you find your X, then what are you going to have to do? Add that to whatever year your base was. Okay, here's a half-life. Does this look familiar with your do you do half-life formulas? Okay. So half-life, this is my rate. Here's my A. This is my rate. I'm halving it. Now, where's the time? My time is X, days. But this is every 65 days, not every day. If I just did this, this would say every day in days. But I don't half-life every day. I half-life every 65. So there's my cycle. You want to be less than 1, just start it at 1 and say less than that many days. That's fine. I don't want you to get hung up on the inequality part. Good. And then the last one. Or you have another half-life. You're half-lifing every 1.5 seconds. Okay, so instead of X being every second, you have a cycle. It's not every second, it's every 1.5 seconds. So again, you started with 2. Did we start with 2? Yep, we started with 2. And we want to see when 1 is left. or we didn't start with 2. Draw, yes, start with 2. Draw a situational graph. And what is the initial amount? If there's only to be 1 gram left. That's a separate problem. This is different than this. So determine if there are 2 grams initially. This is your equation. Then this is a separate problem. If I don't know what my initial is, I got to take that out. This would be my x over here. This is going to be my x. After 1 minute, now here's the thing here. If my time is in seconds, what do I have to do to my 1 minute? Convert that to seconds. This is 60 seconds. You're not going to get, like, if you change this to the x, you have an x here. So this has to get plugged in first. And then just set that equal to 1, see where they intersect. Again, it's going to be very, very small. Very small. You have a very, very, oh, you have a very large amount. Oh, because you're going for 1 minute. Yeah, not 1 second. And you can leave that to me in scientific notation. Your calculator, guys, does an E. So make sure you get where that E means. Times 10 to the 12th power. When you take a half-life every 1.5 seconds, you're reducing it pretty quickly, right? Pretty fast. It's going down, 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 down. Will it ever get to 0? Nope.